Hello students, welcome to Numerical Methods and Integral Transform course. I am Praveen Kumar. In this lecture, we are going to be discussing about fitting of a power curve. So in the previous lectures, we discussed about fitting of a straight line, fitting of a second degree curve, fitting of an exponential curve. So in this power curve is the last curve we are going to be discussing this concept, curve fitting. So in the curve fitting, the fourth curve is power curve. So there are basically two different kind of the power curves we are going to be have. So one curve is y is equal to ax power b. The other one is y is equal to ab power x. So this we need to be remove the power and converting into linear form. So as we discussed in the exponential curve fitting, so we applied log. Similar way here also we are going to be apply the same log. So there exponential we have. To eliminating the exponential, basically we apply log with base c, applied base c to removing this, but where we don't have any such kind, so therefore we are going to be apply just normal log with base 10 on both sides. So in this side also we are going to be apply the same, apply log 10 on both sides. So if you apply log on both sides, so simply just I am writing log, which means the base is 10. Log y is equal to, as we know, log of ax power b. So the previous lecture I have given the formula, log ab is equal to log a plus log b. So same way, log a plus this upper value power value will comes to the base b log x. So this again we are representing in the straight line form. So this log y I am denoting with capital Y is same as log a will be represent with capital A. This is capital B. This is capital X. Now which represents a straight line. So which represent a straight line. So therefore we are going to be use the normal equations. So using of same method of least squares, we are going to be find the normal equations. So the normal equations are summation y is equal to na plus b summation x. And the second equation, summation xy equal to a summation x plus b summation x square. So if you solve this, we are going to get as usual capital A and capital B. But if you see the conversions, what are the conversions? Capital A is nothing but log y. So from this, capital A is log a and capital B small b same. So no need to be convert anything. So where capital X is equal to log x. So this capital X, capital Y to evaluating of these summations we are going to be used. So small b anyway capital B same, no need to be convert anything. Only we need to be understand how we are going to be find small a, because in the question or considering the curve we have small a. So using of these conversions we need to be convert small a, where small a is equal to anti-logarithm of capital A. So anti-logarithm is just base. As exponential will be write e power a, as the base 10 will be find 10 power a. So small a is equal to 10 power a. In that way we are going to be find small a, and small b anyway same. So similar way if you see the second also the same similar kind, log y is equal to log a plus x log b. This is also we are going to be consider the same way, capital Y is equal to this we consider capital A. So small x considering the capital X. So small log b will be considered capital B. Y is equal to a plus bx. So writing the same normal equations will not be change anything, that respective values will be changes. Summation y is equal to NA plus B summation x. Second equation will be having the same, summation y equal to A summation x plus B summation x square. So solving of this, we are going to get capital A and capital B. But where considerations, if you are trying to be C, I am writing the considerations of the second term, where capital Y is equal to log Y. So capital A is equal to log A, capital X small x is same, capital B is equal to log B. Look at, previously only A we need to be changed, but where here the second type of the curve we need to be change both. So we require small a. So as we know, so small a is equal to anti-logarithm of capital A, which means 10 power a. The similar way, if you want to be find small b, 10 to the power of capital B, so we are going to be find. So finally, these are the two ways, or the two different kind of the forms we have in the power curve. So we'll take one example and we're trying to be consider one of the curve and will be solved. Just I am trying to be taking the second one, will be solved. So look at the question. Find the curve of the best fit of the form. So curve is particularly provided y is equal to ab power x, which is nothing but a power curve, to the following data by the method of least square. These all curve fittings are comes under the method of least square only. So this is what the data given. As we know, the previous slide I have given the formulas for ax power b and a b power x is the second one. So in the question we have the second one, just I will write the same brief. Given curve is a b power x, so taking log on both sides, consider equation number 1. The same procedure we need to be write, taking log on both sides, which means log with base 10, log y. So simply I am writing log ab power x, so log y is equal to log a plus the second one. As we know the formula, just now I said log ab is equal to log a plus log b. Using of this formula I am expanding this, so x log b. So finally this I am going to be representing the straight line form. So this I am representing with capital Y, this I am representing with capital A, plus all small letters I am representing with a capital. Log b is bx. So this automatically we have converted into straight line, so which represents a straight line. So if you represent a straight line, so we are going to be use the straight line equations. So using of method of least squares, we are going to be get the normal equations of this particular curve. So that is summation y is equal to NA plus B summation x. Second equation, summation xy equal to A summation x plus B summation x square. If we solve this, we are going to get capital A and capital B. But where if you observe, so we are transforming or we are denoting capital Y is equal to log Y, where capital A is equal to log A. So capital X, small x is same, not need to be change anything. Capital B is equal to, so log of small b. So using of these conversions we need to be find. So after finding AB, but where capital A is log of small a, capital B is log of small b. So but where we require small a and small b, we need to be find this as we know it. So small a is equal to anti-logarithm of capital A. So which means just you need to be find 10 power A. Similar way small b required. So small b is anti-logarithm of capital B, which is equal to 10 power b. So this is the way we need to be find small a and small b. Now just we need to be calculate based on the providing things. Small y, summation y required, summation x required, summation xy required, summation x square required. So based on the requirements, we need to be construct a table. So look at, so previously small x capital X is same. So therefore I am taking the column capital X small x is equal to 1. Where capital Y small y is not same, capital Y is log of y. So that is what. So small y, just for the understanding oriented, I am taking the same given data. Where capital Y is log of y, that is what I am taking the third column as log y. Where summation x square required, capital X. So capital X small x is same, that's what we are finding, x square. Capital XY. So capital X, capital Y. Don't consider this only to understanding, to evaluating this I have taken. Look at that. So summation x required, sum of all these values. Thus we are saying that summation x. Where summation capital Y, not the small y. So first what is y? Log y. Log is log base 10. Just look at in the calculator. As I said, log and ln. So log notation is log base 10. Ln is nothing but log with base e. It is a natural logarithm. So how will we get this? So log 10 value, just substitute, we'll get 1. So second value log 21 will be get 1.3222. So log the third value 35 will be get 1.5441. Similar way, log 59 will be get 1.7708. So log 92 will be get 1.9368. So similar way, log 200 2.3010. Log 400 value is 2.6021. So final value log 610 2.7853. So sum of all these values we are calling as summation capital Y. So similar way we need to be find x square. So squaring of these values, 0 square, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49. So sum of all these values will be have summation x square, it is 140. So summation xy required. So this is small y, we don't consider this column. So 0 into 1, 0. 1 into 1.32, so 1.3. 2 into this value, 3.08. So 3 into 1.7708 will be get 5.31. 4 into 1.9638, 7.8552. 5 into 2.3010 will be get 11.5050. 6 into 2.6021, 15.6126. 7 into 2.7853 will be get 19.4971. So sum of these values will be calling as summation xy. So like this we are going to be find the summations. These summations we are going to be substitute in the previous equations as we know it, right? So we converted this into a straight line. I will be write the equations one more time. Summation y is equal to a plus bx. So normal equations are summation y is equal to na plus b summation x. Second equation summation xy is equal to a summation x plus b summation x square. Where? So first equation summation y required. Summation y is this 15.28 93, which is equal to NA. N is number of observations. 1, 2, 3, 4, 5, 6, 7, 8. So number of observations is 8. 8A. Plus B summation X. So summation X is 28. We are going to be substitute here. So 28B. Next summation XY. So summation XY is 64.1927. 64.1927. A summation X. Where summation X we know it is 28A. Plus B summation X square. Summation X square is 140. So therefore 140B. So now we are going to be solve these equations. If we solve these equations, we are going to be get capital A and capital B. So the capital A value is 1.02115. So capital B value is 0.25428. So these are the capital A and capital B. But where our curve is y is equal to AB power x. Look at the question. AB power x. We require small a and small b. As I said, so small a capital A is not same. Small b capital B is not same. So as we know, capital A is log A. Capital A is log A. Capital B is log B. We need to be converted. So capital B is log B. Capital A is log A. So where we require small a. So small a is equal to this log I am taking to other side. Obviously it will be anti-logarithm of capital A. So anti-logarithm log with base 10. Simply to understand this base it comes here. So 10 power a. So where 10 power of this capital A we are substituting 1.02115. So if you find this, it will be 10.499 something approximately. This is what small a. So similar way small b required here. This log I am taking to another side. So simply anti-logarithm of capital B. So which means 10 to the power of capital B. So 10 to the power of capital B value 0.25428. So small b, if you find in the calculator, it will be 1.7959. So these two values we are going to be substituted in the curve. So the curve is y is equal to A. A is 10.499. A B. A into B 1.7959 power x. So substitute back in the curve. So this is what we can call it as fitting of a power curve. Now we can able to find any value of y by substituting x is equal to. So if you want to be find y value at x is equal to some 0.1, just substitute here. Y is equal to 10.499 to 1.7959, where x is equal to 0.1. Simplify, you are going to be get the y value at any x values we can able to find. That is what the advantage of this curve fitting. So in this curve fitting we discussed many different kind of the curves. So in this lecture we discussed about fitting of a power curve. So in the curve fitting area we discussed straight line, fitting of a straight line. The second one is fitting of second degree curve. So fitting of exponential curve. So fitting of power curve. So these are the curves we discuss in this power curve sessions, right? Thank you so much.